Hello everyone, I am Rohith Prem from CSE department. Today I am going to explain about k-means algorithm. Okay, what is k-means algorithm? It is an unsupervised machine learning which is used to group similar data points together into k clusters. Then it finds the k point in a data space called centroids that represents the center of these clusters. Then each data point is then assigned to the nearest centroid forming those clusters. Then this process effectively separates the data into distinct groups, making it easier to understand and analyze. Let us see how this k-means algorithm works. First, we should select k random points. Next, we can choose one of our data points, or as I did here, choose totally random coordinates. These points are called centroids. Then we assign each data point to the nearest centroid. This is how we get our first set of clusters. Then we move the centroids to the center of current clusters, which can be found by averaging the coordinates of data points into each group. Then we reassign data points to groups based on their distance to the centroids and move the centroids according to the average coordinates of the data points in each cluster. Then reassign and recompute the centroids again and again. We repeat these two steps and we will stop when no change in the clusters happen anymore. As you can see, we can discover clusters among our data points using the k-means iterative algorithm. Okay, now let us implement this algorithm using Python. Step 1. Import necessary libraries and load data. Here, these lines import two essential libraries in Python: pandas, which is used for data manipulation, and matplotlib, which is used as a plotting library for data visualization. Next, we are creating a data frame, and using the panda function we are reading the CSV file mall_customers. In that file we have the customers who is visiting the mall frequently and their data embedded in it. Okay, step 2. Explore the data. Data.headof. This line simply displays the first few rows of the data set, which allow you to get a quick look at the structure and contents of the data. Data.info. It provides a concise summary of the data set, including the number of non-null entries in each column. Next, data.isNullOf.SumOf. This line checks for any missing values in the data. If so, the sum function calculates the total number of missing values in each column. Next, step 3. Determine optimal number of clusters using elbow method. In this line here, the k-means class from the sklearn.cluster module is imported. K-means is a clustering algorithm which is used to partition the data into distinct groups based on the similarities. Next, the WCSS we are creating an Next, we are creating an empty list where the variable name is WCSS, which means within cluster sum of square. It is a metric which is used to evaluate the performance of a k-means algorithm. It represents the sum of square distance between each data point and it is assigned centroid within a cluster. Next, in this, we are creating a for loop which iterates from a range of numbers from 1 to 10, which fitting a k-means model to the data for each number of clusters. The in_clusters parameter specifies the number of clusters to form, while the init equal to k-mean++, which specifies the initialization method for centroids. Next, the k-means.fit The fit method is used to fit the k-means model to the data. Next, the inertia attribute. We know that append means appending into that WCSS list, but that k-means dot inertia underscore attribute returns the WCSS value for the fitted model, which is then appended to the WCSS list. Next, we are using the matplotlib library for data visualization. This set of plots plot the numbers of clusters against the corresponding WCSS values. Okay, this plot is also known as the elbow method, which is used to determine the optimal number of clusters. Here you can see the example that this elbow is typically where the rate of decrease in WCSS starts to slow down, indicating the optimal number of clusters. Next, step 4. Apply k-means clustering. Here, a k-means model with a fly clusters is initiated and fitted to the data. The predict method is used to predict the cluster labels for each data point in the data set. Next, step 5. Visualize the clusters. This line adds a new column named cluster to the data from data which we used in the step 1, which contain the predicted cluster labels for each data point. Next, these DF0, DF1, DF2, DF3 and DF4, these lines create separate data frames for each clusters by filtering the original data frame based on the cluster labels. Next, we create a scatter plot to visualize the clusters. Each cluster is represented by a different color, and the x-axis represents the annual income, while the y-axis represents the spending score, which ranges from 1 to 100. The plt.legend function adds a legend to the plot to indicate which color responds to which cluster. Next, at last, the plt.title of this function sets the title of the plot. Application of clusterings. We use clustering in our day-to-day life, such as recommendation engines. In recommendation engines, clustering helps group similar items to personalize recommendation based on past behavior. Market segmentation. Here, clustering identifies distinct groups of customers with similar traits or behaviors to tailor marketing the strategies. Next, the social network analysis. Clustering uncovers the communities or group within the network, aiding in understanding the network structure and dynamics. In the medical imaging, image segmentation and anomalogy detection, clustering assists in identifying patterns, and detecting anomalies in medical images for diagnosis and treatment planning. Next, thank you. I hope you understand this concept well.